This is question number 12, chapter 3, review exam 2 for math for liberal arts. So this question is asking us to write this in an argument in symbolic form. The team wins if Tony plays. Tony did not play, therefore the team did not win. So how do you write this in an argument in symbolic form is first you have to tell me what are the statements for P and Q. So in this case, we got two statements. The first statement in this case will be the team wins. And the second statement is Tony plays. So since we got these two statements, so we can write this in the form that if the team wins if Tony plays. Now since the if is in the middle, so this is your P. Actually, this is your Q, since we denote that as Q, and this is your P. Now, the if in this case will tell us that we have to write this backwards. So, in order for us to write the team wins if Tony plays, it will look something like that. Q arrow P. But Tony did not play, so Tony plays is Q, so Tony did not play in this case is a negation Q. And the conclusion is the last statement. It says therefore, so the three dots means therefore, the team did not win. So the team did not win is actually negation P. So this is how we write this in an argument in symbolic form. I want you to point out here that if you have the if here in the middle, the Q and the P is being switched around. But if the if in the front, then we can write this as P arrow Q. But since the if is in the middle, so those two needs to be exchanged. Now, how do we write this in a conditional statement? So, conditional statement in this case is your first premise and your second premise, and the conditions goes to the conclusion. So, your first premise is this. This is your first premise, the first sentence we have. The second sentence is your second premise, and the last sentence is your conclusion. So how do we write this in the conditional statements? So the first premise in this case is Q arrow P. And then we have the and symbol, because there's an and symbol. The second statement in this case is a negation Q. And this goes to the conclusion, which is negation P. So this is my second premise, and that is my conclusion. Now we have to build a truth table based on this conditional statements. So since we got P and Q here, so we're going to use P and Q in this case. So what we have here is Q arrow P. That's the first part. And then we have the and. It's Q arrow P. That's an and. We got a negation Q. And all this is under another parenthesis, so you have double parenthesis here. This is negation Q. And there's an arrow sign here. And then we got a negation P. So this is how we set these conditional statements into a truth table form. So Q arrow P in this case is a conditional going backwards. So true to true is true. False to true is still true. But true to false is false. False to false is true. So in this case, this is the conditional that goes Q to P. Now the negation Q means is the negation of this column. So that will become false, true, false, true. The negation P in this case is the negation of true, true, false, false. So in this case, we got false, false, true, true. Orders of operations, we do the parentheses first. So we have the and statements here. So and in this case is one is true, the other one is false. We will get false. Double true statements, you will get true. Double false statements, you get false. Double true statements, you get true. So again, gently scratch those two off. And the last one is a condition. So condition in this case is, if both cases is false, you get true. Now if the first case is true, second case is false, you will get false. False to true, you still get true. true to true is you get true. So the last column that we do is our answer. Now, since all these answers, if they are all true, then the argument is valid. Unfortunately, we got one false here, so the argument in this case will be invalid.